क्या वो सही करना है क्या? They are here for okay. Hello everyone, how are you after a long break? How are you everyone? Are everyone able to join? What students are writing? Where I can see? Acha, here. This na? And how many are 98?
100 other papers.
So they are different. They are different, or both are same. Both are both.
Also 100 papers. Also 200. Also 100 papers.
So these 99 are someone else, and they are someone else. Okay. So how will a student choose where to join, this or this?
This is recharge.
Acha.
Address is recharge.
Okay. Good morning, everyone. Good morning. Very energetic. Good morning. I think this short break have given you a large leech of energy. Everyone is writing so fast, so elongated version. Very good morning to all of you. Very good morning. How are your Dasara celebrations? I hope it must be divine. You must have seek some blessings from Goddess Durga, I think. Is everything okay? Yes. Okay then. So I am reminding you what we were talking just before the break. Can anyone tell? Does anyone having that memory that you can tell me what we were doing? Oh, we were doing money transactions in banking. Yes, banking of roads. Yes. Swati is very playing very safe. Circular motion. She told entire chapter's name. Yes, circular motion was there definitely, and the topic was banking of roads. Very nice. So I will not go straight to the new topic. First of all, we will deal with the previous topics only of the circular motion, so that we can again get into touch with the previous topics that we will utilize in the further topics. Oh, physics. We were dealing with physics. Very good. So see. From this problem, we started horizontal circular motion. I am giving you some practice questions, just that. This question we already dealt. Here is a support, and if I rotate this into a this I told you, no, this is our childhood activity. Tie a stone to the end of a thread and do above your head the horizontal circular motion. Okay, there. To maintain the particle under that circle, our hand must apply some force, and that force that my hand is applying is visible in the form of tension of the string, and that is the tension that I can ask you, that what is the tension here. You will definitely tell me the answer. Tell me fast. Next, what I will do, I will do something extra. Second question is interesting one. First one is a small child handling only one mass. Second one is a slightly bigger child, stronger one. He must be playing cricket, so he has got stronger. He is handling two masses. Okay, he has taken two threads, each of length L. First thread is having 2 m mass, and there is second thread also connected to m mass, and now he is doing the same thing. This symbol I will every time use for fixed point, fixed axis. So here my hand is there and I am doing circular motion here. So both entire system is doing circular motion above my head like that. So I can definitely tell you that if this is first string and this is second string, you have to find T1 and T2. In exam, they will ask you ratio of tension in the two strings. Questions like that are asked. Okay, so this will be a very easy question in the exam, and if you learn this time, then this will also fall under the easy category only. Okay, so how can I approach? How can I approach? The approach is the same like this one. Here, what I told you, just draw the FBD and see. I will be doing the question in two frames. Okay. Previously, I was doing using centrifugal force because that was easy to understand. Okay. But in exam, many times they ask you the FBD in ground frame also. So that is the purpose of revisiting this question again. Okay. So everyone concentrate now. Everyone concentrate. I am hoping that everyone is concentrating. See, in ground frame, GF I will use in ground frame. If standing on ground, I am seeing this mass. It is rotating like that, and standing from there, I am seeing this mass. Means I am ground frame. So I told you in ground frame, pseudo force is not visible. Centrifugal force is not visible. So I will not draw that in this FBD. In ground frame, what I am able to see, this mass is actually doing circular motion. So under only one force tension, no pseudo in ground frame. Okay, this is the center, and like this. But in ground frame, complete circle is visible, and what I have told you, for a circular motion, centripetal acceleration is a must. So in ground frame, this mass is visible to be having centripetal acceleration that is equal to v square by r, and r here is L. So what you can write the equation, F equal to ma. What Newton told into your ears, I always tell, force equal to ma. So force is T and m is m, a is v square by L. So this is one answer. Or if they give you in omega terms, it is omega square L. So answer can also be written as m omega square L. This is the solution in ground frame. And what is the solution in rotating frame? What I told you, if you sit on this mass, rotating from frame means what? Where many questions are asked. Centrifugal force is visible in which frame? Where is the observer? They will trap you. That is, they will give you in first option. Observer is standing at the center of the circle, and centrifugal force is visible. It is correct or incorrect? If observer stands on the circle, will centrifugal force be visible to him? It is incorrect. Centrifugal force will not be visible to him because center of the circle is not moving. Center of circle is ground frame, and in ground frame, centrifugal force is never observed. Okay, in ground frame, centripetal acceleration is observed. Rotating frame, what I told you, remember everyone, theoretical questions can be asked. You have to sit on this rotating mass, okay, or you have to rotate with the mass. Whatever is the language, when you will rotate with this mass, I gave you the example of a rotating car, and you are all, a friend is sitting beside you and car is rotating. You are seeing your friend always sitting beside you. Every time you are seeing him in equilibrium, never you see him to be doing a circular motion. Okay. So in rotating frame, this mass, if I sit on here, I will always see this mass lying below me. So every time I will see equilibrium. In rotating frame, equilibrium along radial direction is observed. Equilibrium along radial direction is observed. This is the difference of the two frame. In ground frame, acceleration is observed. Centripetal acceleration towards the center, T towards center, and m omega square L away from center. This away from center is centrifugal force, and that equation, same answer sheet is coming, m omega square L. You solve from this or you solve from this. Both methods are giving you same answer. Interpretations are different. Whoever had confusion, it must be clear now. I think everyone have got you. Copy. Every question I will solve in rotating frame only. Rotating frame is easy to deal with. Okay. We did death well also. There is a nice wrap on death well. You can go and visualize the wrap along with seeing the death well motion. Okay. My purpose of the question was not this question. Okay, everyone? Purpose was this question. I need answer. That's why I'm waiting. In 1 minute, tell me the answer. Draw a BD of the two masses differently in rotating frame. Just visualize on what radius each mass is rotating. That will give you an idea of what to be used in problem solving. See, this question, both strings have length L. If I ask you, this yellow mass is rotating on which circle of which radius? You will say that radius is L. Yellow mass is moving on this circle. Blue mass, this is the fixed point. Now here is my hand. I am rotating here like this. Okay, here is my hand, so this is the center. Blue mass is rotating on this circle. Everyone must feel this. So blue mass is rotating on a circle of 2L and yellow mass is rotating on a circle of L. This is the crux of this question. Now, whatever way you want to solve this question, what I tell you, for solving questions easily, use rotating frame. First, what you do, draw a BD of blue mass. Sit on blue mass and draw its FBD. So when I am sitting on blue mass, here this is the first string and this is the second string. In second string, I am assuming tension T2. See, tension always pulls the mass. Okay. So see, T2 will act like this. It always pulls now. So blue mass is towards right, so it will pull towards left. Yellow, this second string is also connected to yellow mass. What all of us in a hurry do a mistake that on yellow mass we draw T1 and on blue mass we draw T2. This is wrong. On blue mass, it is correct that T2 is done because only one string is connected to blue mass. But yellow mass is connected to both string, now first string and second string. So both tensions will be acting on this yellow mass, not only the tension of first string. This is the mistake in a hurry we do in the exams. So do not do. I am reminding you beforehand only. So see, on blue mass, what I can say, T2 is acting towards left and outward. Outward means away from center. Center is here, so away from center means what? What mass I gave you? Inner mass, yellow mass 2m I gave you, outer mass m I gave you. So m omega square into what is the radius? 2l. Blue mass is rotating on a radius of L plus L 2l. This is the FBD of T2. Now I am drawing FBD of T1. I am drawing FBD of T1. Concentrate. Why there so much silence? Why is there so much silence? Everyone get energized. Circular motion is in full flow. Come on, everyone. So yellow mass, see, both strings are connected. So string towards left will pull it to the left. String that is to the right will pull towards right. That is what is meaning by pulling force. This is tension you have drawn. Now I am sitting on yellow mass. To draw a video of yellow mass, I sit on yellow mass, means I am in yellow mass frame. So centrifugal force will be m omega square into L, because 2m mass is rotating in a circle of radius L. This radius you have to guess always correctly. Hold your patience, you will always tell it correct. Okay, see, answer is coming. T2 directly comes. T2 is coming to be 2m omega square L. Put it here and you will get T1 also. T1 equal to, and see, inner mass was 2m. Inner mass was how much? 2m. Yellow mass I gave you 2m now. So when you are using the formula m omega square L, put the actual value of m. What is the actual value of m for yellow mass? 2. So put 2m here. So T1 is 2m omega square L plus T2, and T2 is also 2m omega square L. So T1 is equal to 4m omega square L. T2 is equal to 2m omega square L. What in exam they will ask you? They will ask you the ratio of two tensions. Okay, so hold your nerve and just write. See how easy the question is once you have understood that how centrifugal force is drawn. It is essentially Newton's law of motion question, just that one extra force you have learned this time. That force you have to draw again and again. Sit on the rotating mass and keep drawing centrifugal. Everyone now, I think it is okay. Okay, everyone. Okay, everyone, come on, reply. Hello, hello. Are you listening? Hello. Recall your black energy from deep inside you. Recall your black energy. Recall your black energy from deep inside you. That black power is important. Too much powerful that is. Come on, everyone. Come on, everyone. Tell me, everyone. Come on, clear. Yes, yes, yes. People are telling yes, yes, yes. So this was the question that were in the domain of the previous things. Now, on the same thing. Conical pendulum. I will keep giving you questions like this, but first let me start a new topic so that syllabus progresses also. Questions are unlimited. I can give you anytime, anything. Okay. So I will give you more once this topic is over. Write conical pendulum. See, what simple pendulum was? First of all, to study conical pendulum, I need to understand the difference of motion in simple pendulum and conical pendulum. This is the simple pendulum you all must have watched in decorative wall clocks. Okay, motion keeps going like this. Simple pendulum. See, mass, the bob goes down and then goes up. Stops, stops, stop. There is extreme position. Stops here. And then again return. Again returning means again going down, 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 lowest point, and then rises to the highest point. Means simple pendulum, vertical displacement is there. In y direction, displacement is there. That is absent in conical pendulum. This is the basic difference. This is the basic difference. Now see the motion. This is the mass. And motion is happening on this circle. Motion is happening on this circle. This diagram must be looking like a inverted cone to you. Inverted cone to you. That's why the name conical pendulum is coming. And see, the mass is always moving on this flat circle. On this flat circle, I am drawing in yellow. See. Okay, so there is never even an inch of displacement in y direction. Okay, so there is never any displacement in y direction, means I can take a guarantee that equilibrium in y direction is for sure happening. Okay, That was not the case in simple pendulum. There was never there was not an equilibrium in y direction, but here equilibrium in y direction is there. Okay, so that is what I have told you. Now I am drawing the diagram solely of conical pendulum here. See now, what were you doing above your head up till now? Now you will do like this. Hold a string in this you can do in your home. Take a string. Previous problem was like this. Above your head you were rotating something like that. Now, now what you have done? You have a string connected to you. Now you are doing like this. Okay, tie a stone to your string and in your home and do like that. The motion that will be visible if you try to fix your palm at a vertical. Your palm should not go do vertical movement. If your palm is not doing vertical movement now, that bob will also not do any vertical movement. Someone, Hari Prasad is telling us in the previous question, is not T2 m omega square into 12. Same thing, na? What are you doing, Hari Prasad? M omega square into 12 is written, na? And that too I can write here. So 2m omega square L. Okay. Maybe some brain fit. You have misinterpreted something. Same thing it is written that you are telling. Okay. Now see. First of all, what in exam they can ask you FBD in ground frame. FBD in ground frame means stand on the ground and see this mass. Okay. So if this is M, downward will be mg, definitely sure. Here will be tension. Only these two forces are acting. Only these two forces are acting. And since I am in ground, I will be actually seeing this mass to be moving in this circle like this. Okay. So since this mass is moving in a circular motion, I will say that it also has circular motion means it is having some acceleration towards center. Okay. So acceleration is not drawn in FBD, acceleration is drawn besides FBD. Okay. So I will not draw arrow on the mass. I will say that acceleration towards center is AC. This is not part of FBD. This is apart from FBD. So that on FBD, what is drawn? Force, not acceleration. So separately say that acceleration is visible in ground frame. If they ask you what forces are acting in ground frame, T and mg only. Now in rotating frame, what I can tell? This is mass. Now see, downward is mg. This is T. Forces that are acting in ground frame always act. Okay. What extra is in rotating frame? If you sit on this mass and now you are seeing this mass, this is the difference. Then you will not be seeing any circular motion happening. Now you will see centrifugal force away from center of the circle. And now center is not this point. Circle is here. On this circle it is moving, so do not mistake center to be this point. Center is this point. Okay, this is center of the circle. Okay, so away from center means this arrow. People in a hurry draw arrow like this, away from this point. This is wrong. Okay. Oh, what I have done. So correct arrow is this one. So I will write m omega square L. M omega square. And I am telling you the specifications, where r is radius of the circle. In exam they will give you length of string and this theta. So first of all I can say you can definitely say na, in this triangle you can say L is hypotenuse, L sine theta is r. You can say L sine theta is r. L sine theta is r. And this I need to write the equations. Now what you do? I have drawn this for you. I will again draw this arrow. Before I draw these arrows, before me, you visualize what should I do. Okay, I am repeating the same thing. Before I write it should occur to your mind that which arrow I should draw, which length I should write. This is theta, this is L. Before I write this length, tell me what is this length. In your mind, you tell, I will hear. This is R equal to L sin theta, very nice. FBD, downward is mg. This side is tension. I am in rotating frame. Here is center. So away from center, always speak like this while you draw the question. Okay. Well, what I am speaking away from center means this side is m omega square r. And what is r? L sin theta. This is your FBD 3-force equilibrium problem. It is now. What I told you now, what I told you, there is no any vertical movement. All movements are in this horizontal circle only. All movements are on this horizontal blue circle. Never ever it has gone vertically up or down. So I can definitely say net force in y direction is 0. So equate forces in y. So take components. So I am drawing a simplified FBD in components for mg. I will not disturb, it is already in a straight arrow. M omega square L sin theta, I will not disturb, it is already a straight arrow. T, vertical component cos theta, horizontal component sin theta. Theta is angle with y axis. So in y, what will come? Cos theta. So T cos theta this side, T sin theta this side. So see, your FBD has been complete. What I told you, y direction FB, net force is 0. So y direction, what is that? T cos theta up equal to mg down. So I will write T cos theta up equals mg down. And what I told you, I have drawn this FBD in rotating frame. In rotating frame, what I always tell you, there is equilibrium along radial line. So what is radial line? X direction. So in X direction also there is equilibrium. In not ground frame, in rotating frame. So Fx equal to 0 means equilibrium along radial line. Equilibrium along radial line in rotating frame. So I can say T sin theta. See, T sin theta towards left will balance m omega square L sin theta. These two equations I have to make. Okay, so copy fast. First I am shifting to the previous slide. Draw this one, ground frame FBD. Second diagram already repeated in the next slide, so do not copy this. Copy the first diagram in yellow in string, blue circle, and white forces. Hello everyone, come on, tell me, how was conical pendulum? Conical pendulum is nice. Have you visualized how the motion is going on? It's all about visualization. Once you tell yourself that motion is like this, equations will always be common sense. Once you are convinced that in conical pendulum, mass is not going up, not going down, you can always write equilibrium in y direction. This is the difference of conical pendulum with simple pendulum. In simple pendulum, up down motion was there. Here, no such motion. Copy fast. See, to make you understand, I have to write all these. In next slide, I will tell you how you can write so fast. Here I have to introduce equilibrium along radial line in rotating frame. Okay, once it is in your mind, no need to write. Just for your revision purpose, that for if you revise and you get confused, see this line and get it clear. Have you done copying? Are you finished with copying? Yes, Akruti has told yes. So see, again, before me, tell yourself that what I should write. If questions are asked from conical pendulum, people tend to skip this. That's why I am drawing it time and again before your eyes, so that it appears to you that you have done it many times and you get confidence in this question. Tension, downward, mg, wherever you are sitting, speak. Here center, away from center, what force? M omega square. And directly now tell me, what is R? R is L sine theta. This is theta, so alternate angle, this angle is also theta. Directly tell me. uh, X direction equilibrium I am writing. T cos theta. Sorry, T sine theta towards minus I, and that is equal to M omega square L sine theta. And what is Y equation? T cos theta in vertically up is balancing mg. That is what we wrote in the previous slide also. Now what you need? They will ask you what is this angle, or what is the, see, either they give you theta and ask you what is the time period of motion or omega, or they will give you omega and ask you what is the theta. So both are relatable, just divide. What you get on dividing, sine by cos is tan theta. Why tan theta? Sin theta is cancelling itself. See, sin theta cancel na? Now divide. So 1 by cos theta is equal to m by m cancels. You get omega square L by g. So see, if they ask you theta, tell what you tell. Cos theta equal to g by omega square L. If they ask you this, or maximum time they give you theta and ask you omega actually. So I am forming a formula for omega actually. So omega square equal to what you get, L by g cos theta. So omega equal to under root L by g cos theta. And since the mass is moving on a circular motion, so if after some definite time, it must be coming back to its starting point. Then again go to the circle and come back again to this point. And again go to the circle and come back again to this point. So after some fixed point, it must be coming repetitively at this initial point. And that's why they can ask you time period. So if I know omega, time period, I already know 2 pi by omega. So if I know omega, I know time period t equal to 2 pi by omega. So what it will get? 2 pi under root. Cos theta, I have slightly made it wrong. I did a mistake in cross multiplying. See, cos theta was g upon omega square L, no problem. I was writing omega na, so cos theta will merge with this L. So omega square is equal to g upon L cos theta. Previously I merged cos theta with g actually. So no problem, it happens. So omega square is g upon L cos theta. So omega equal to under root g upon L cos theta. So t equal to 2 pi by omega means 2 pi under root. Now divide L cos theta by g. Do your calculations, copy. Definitely. You will get tan theta equal to V square by RG. I will tell you. This is the standard way of doing calculation. Actually, this answer I will tell you to remember. Okay, so in this format, people remember this answer. Calculation is a personal way of doing. But if you take tan theta, then tan theta by sin theta will come. How will you how will you operate that? I can cancel at the first step only sin theta. So only cos is remaining. If you handle tan theta, then you will have to handle sin theta also. So tan by sin will be coming together. So tan by sin you will have to write cos theta sooner or later. Okay? Because tan theta is not independently coming. Sin theta is also there separately from tan theta. Now see, answer of this is slightly like simple pendulum only. In simple pendulum, what is time period? 2 pi root L by G. And what is here? 2 pi root L by G is there, but a cos theta is coming in numerator. Okay, so that much adjustment is there. So conical pendulum is a slower version. And this is not an oscillation. Simple pendulum is an oscillation, to and fro motion. Simple pendulum is an oscillation like that, to and fro, to and fro. Conical pendulum is this motion. Understand the motion. Tip of this marker is conical pendulum motion. Okay, and this marker itself is the string in this problem, like this. If you focus your eyes, do your yoga and focus on this tip of this marker at this point. You do this with your pen now. Keep your pen in front of you and now observe this motion. Tip of this marker is doing conical pendulum motion, and that time period is 2 pi root L cos theta by G. So T equal to 2 pi root L by G is coming here also. Extra part is cos theta is coming, and this I have to remember. This same problem can be asked to you. They will tell you that purchase a begging ball. Okay, begging ball is there. Everyone of us must have not used it, must have seen it. A begging ball. Okay, a smooth begging ball you purchase, and that you play goalie. That you tell goalie. Everyone of you have told me that you tell me goalie. You force a goalie to do a circular motion on this ball. See, you purchase this begging ball and become a scientist doing some physics here with the begging ball. Good days for you have come. See, you are doing so many practical physics. Now see, what I told you, take a goalie, a small sphere, and enable it to do a circular motion here like that. Okay, so this is also doing a horizontal circular motion. Okay, I will tell you all the answers here, all the calculations for this physical problem is identical to the problem you just concluded. Oh, what is identical? Because motion is circular for here also and here also. Okay, draw the FBD. Do not get afraid if they give you slightly adapted questions like this. Okay, why I am saying that problem is same? Because see, the role of tension here, tension was binding this mass. Here normal reaction is binding this mass. Okay, this ball is on the surface now, so normal reaction always passes through center, you must be knowing. So normal reaction is playing the role of tension there. Now see, FBD is identical or not. Here it is mg, and see on this circle it is moving, so away from center is centrifugal force m omega square into r is this radius. Exact same FBD, so exact same answer will come. Okay, so when these types of questions come, do not get scared that, oh sir, hi Rabba, what sir has given me. Okay, like that. So in this problem, what they will give you, since this is a sphere type of thing, they will give you radius of a sphere, not a smaller. There also, not length of string they give you. Here they will give you radius of a sphere. Okay, so that will be capital R, no problem. This will be theta. Definitely this will be theta. Okay, so equation writing again. See, n cos theta in vertically upward direction, balance mg downward, n sin theta in n sine theta towards left. See, this is n and this is theta. Theta was with y-axis, so y-axis cos, x-axis sine. N sine theta is m omega square small r, and small r is capital R sine theta. Exact same. Wherever you have written t in the previous problem, there is n here. So answers will be identical. I always tell you, identical mathematical equation give you identical answers. So don't get scared. Question answer will remain same. What new thing they can ask you? If they ask you this question, they can ask you normal reaction. And if they again ask you the previous problem, they will ask you tension. So we have not calculated that. We will calculate it now. So understand now. Now concentrate everyone. This is tension. This is normal. Sorry, what I did. This is tension. This is mg. And this is, I think you all remember, m omega square L sine theta. Hey, do not say that you do not know. This is r and this is theta. So L sine theta is smaller. So see now, for tension, what I can write? Just square and add this equation one way. Okay, or see, these three forces are in equilibrium. These three forces are in equilibrium. This is the better way to interpret. Okay, so consider it, everyone. These three forces are in equilibrium or not? Tell me. Yes, in equilibrium, definitely. So if these three forces are in equilibrium, the resultant is zero. Means I'm naming first arrow, second arrow, third arrow. First and second arrow combined is balancing third arrow. Second and third arrow combined is balancing first arrow. First and third arrow combined is balancing second arrow. This is the meaning of equilibrium. Okay. So if they are asking me tension, what I will tell who is balancing tension. Tension must be equal to that. If I am applying 5 Newton force and I know that I am perfectly balanced, means every other one who has balanced me must be applying a 5 Newton force. So here, to calculate tension, I will calculate tension is equal to what? Balancing force. And who is balancing tension? Means who is balancing third arrow. Who is balancing third arrow means first and second arrow. So first and second arrow must be balancing this tension. So tension I can definitely write is the resultant of first and second arrow in magnitude. Tension is equal to the resultant of first and second arrow in magnitude, and first and second arrow are at 90 degrees. So what happens at 90 degree? Pythagoras theorem. If I tell you that a force A is there, a force B is there, what is the resultant of A and B? You will tell under root A square plus B square. And this question is like that there are three forces. A force is C, a force is A, a force is B. Okay, and it is in equilibrium. So if they ask you C, what you will say? C is balanced by A and B, so C must be equal to resultant of A and B. So C must be equal to resultant of A and B means under root A square plus B square. So for equilibrium, C must be equal to root A square plus B square, but opposite to it. So my answer, so in the exam, if they ask you next, now that you know what has to be done, just add it Pythagoras wise. So under root m square g square plus m omega square L sine theta whole square. Like this tension is calculated. Copy. Here same thing I can write for normal. Here normal is same answer, m square g square plus m omega square r sine theta. Hello, come on everyone, tell me, have you understood? Communicate loud. Have you understood the things? Come on everyone, I need everyone's response. Have you understood? Very good, Gitanjali, Swati. Where are the rest of the people? Come on, write. Give your fingers some ability to text. You text too much on Instagram, you text too much on many things are there. I am not remembering the name. Yes, yes. Okay. To make things light, on a lighter note, I am giving you a lighter question. Okay. Then again, I will come back. So, this is a very interesting and easier topic. VCM. Up till now, our circles were horizontal ones. Whether we studied banking of road, there also circle on which our vehicle was turning was doing on a horizontal circle like that. Conical pendulum also a nice example of horizontal circle. Death well, a well in which actually death does not take place. Okay, for death to not actually take place, we derived conditions there. That motion was also a horizontal circle, and I told you, you can. A new rap has come on YouTube. One Kerala singer is there. There in background, he is singing, and in background, people are racing on a death well. You can enjoy that video. Okay, so all these are nice examples of horizontal circular motion taking place in our daily life around us. Now, vertical circular motion, you must have gone into a fair. That giant wheel is there. Every child demands to be sitting on that giant wheel. But every parent is telling every child that don't go there. Okay, so now circle will happen like this in vertical direction. Now we are shifting from this horizontal to a vertical. You must have understood the difference. Okay, so the first thing that I will tell you, understand the basics. I tell you, just a basic question, that if I take a string, I tie it here. This symbol I already told you, I will tie it here. And now I have placed a mass is there. And this mass I am whirling in a vertical circle. Draw a vertical circle and say that this motion is due to a mass m connected to a string of length L fixed at its center. I am telling you that suppose its speed is root 6gl. Now see, since the motion is in vertical circular motion, what I will tell you, gravity will come into play. Gravity will come into direct play, direct conflict will be there. Okay, so let us get ready to manage that. I am telling you that if a simple question, I promise you the question will be easy. I am just asking you, tell me the speed at the top of circle. Find speed at top of circle. At top of circle. This is the question. Do not get afraid. Do not get afraid of circular motion there. Okay, just apply work energy theorem. Just apply work energy theorem. This is a question of work energy theorem. So how will I approach? How will I approach? That I will assume that suppose it is somewhere at the top. It will come now. Bottom is initial position for me, I. Top is final position for me, F. I will assume speed there is V. Speed there is V. Directly apply work energy theorem between these 2 points. Okay. So it has. So for work energy theorem, we have to visualize the FBD. So in FBD, work energy theorem. Right now I am in ground frame. Even if you do in rotating frame, I have already told you that radial forces never do work in circular motion. Radial forces does not never do work. Okay, so tension is not going to do work. I told you zero work case, the first case in work energy theorem. Tension at any point visualize na, tension is like this, mg is like this, and centrifugal is like this. Tension and centrifugal are radial forces. They will not do any work. Okay, in ground frame, Centrifugal force is not there at all. So no question of work. Only tension and mg are in ground frame. So tension will not do work. So all the work is done by gravity only. And I told you, if work done is only by gravity, you can use directly v square equal to u square plus 2s, because gravity's work does not depend on path. Okay, either remember my sentence that if only gravity is doing work, no need to think that much, directly go and use v square equal to u square plus 2s. Okay, so first I am using that. Okay, so v square equals u square plus 2s. So v square equal to u square means 6gl, u square means 6gl plus 2. Since it is going up, so a is minus g. And displacement, how much displacement? 2r. L plus L is 2l. Like this you could have done this. So v square is 2gl, v is under root 2gl. Either do this thing or a proper method, work energy theorem method. So what I will tell that while applying work done by gravity, what I told you, just see the level difference. Initial level this one, final level this one. So how much is level difference? Total 2L. Total, this is L and this is also L. So gravity has done minus mgh and h is 2L. This much work is done by gravity. Tension has done no work, so I'm not writing. That is equal to delta K. Delta K means half m into final velocity square minus initial velocity square means 6gl. See, same equation you will end up. M gets cancelled and you will get minus 4gl equals v square minus 6gl. See the beauty. So you have got what is called answer. So v square equal to 2gl. Once you figure out in a question that only gravity is doing work, get ready to use the equation to get a quicker answer. No problem. This also gives you a quicker answer. So root 2gl is the answer. Root 2gl is the answer. This is how you can calculate every time. Now, without wasting a single second, okay, tell me speed at this point. Tell me speed at this point. Right now, where I have calculated, I thrown the ball at the bottommost point and I asked you at the topmost point. In exam, they will ask you, find speed at a point till which string has turned by 180 degree. Means they have thrown, if they have thrown from bottommost point, they are definitely talking at the topmost point. Now I am asking you, find the speed at a point till when string has rotated by 90 degree or 270 degree, like this. So now I have to find this speed. Operate the same method and tell me the answer fast, fast, fast. Tell me fast. I have made you revise the work theorem again. Okay, so try to do it correct in the first attempt. Everyone can do it correct, but just you need is a try. Give it a nice try. Come on. Come on, increase your jaws, increase your jaws. Come on, increase your energy level. It's all about energy. Get out of your lethargy level, get out of your comfort zone and try to solve it. I am confident that you can solve it. Why not you can solve? Everyone, tell me the answer. Yes, yes, yes. Some answers have popped out and that is correct. Very nice. Congratulations, Gitanjali. You have done it. Some other persons have also told, but their names are not visible. Yes, root 4gl, everyone who is getting root 4gl is correct. Very nicely answered. Yes, yes, Vinay, yes, Vinay, very good. There is not any difference between this question. What I have told now, that a circle is there, bottommost point I already know, root 6gl, no problem. If they ask me here, I will assume V here, no problem. This is initial point, this is final point. Guess, Guess and observe the way I always initiate a question if you are confused in any attempt. That how if your hands shiver like this, then try to observe the way I start. Your fear will go. Okay, so see here. What I told, if only gravity is doing, first you can apply v square equal to u square plus 2s, you can apply that. But genuine method is work energy theorem. So what I will tell, from initial to final, tell the level, show the level by your palm. Initial level is my this palm. Final level is this palm. What is the gap between my two palms? Simply radius of the circle means length of the string. So it has gone up by length L. Gone up means gravity will do work minus mgl. Tension has not done any work. So this is equal to simply half m v square minus u square means what? 6gl. Okay, gets cancelled. So see, this becomes minus 2gl this side. So v square equal to 6gl minus 2gl. So simply v square equal to under root 4gl. If I ask you this point, at this point, I think you will say in one go, you will say in one go, you will say in one go. Tell me fast. If I ask you at point D, is calculation needed, or you can say answer is same as point B? Tell me loud, same or different? At point D, is speed same as at point B or different? Same or not? Come on, everyone. Very less number of same I have obtained. Everyone tell same. If you do not tell me same, it will be same. SHAME. I will start typing SHAME. Oh, yes. Very good. SAME I am getting now. Very good. Because they are at same level. Even if I compare A and B or I compare A and D, same work energy theorem I will have to write. Okay, compare from A to B or compare from A to D. In a D point also path is this, but work done by gravity does not depend on path, na? So from A to D also work done by gravity is same minus mgl because level difference is exact same. So answer will be same equation means same answer. So observe the answer now. See, observe the answer now. Maximum question of vertical circular motion hover around these 4 points only. These 4 are special points. These 4 points can be remembered and used like common sense, and remembering is very nice. See, here what was there? I gave you 6gl. Okay, on rotating by 90 degree from bottommost point is important. Bottommost point, from bottommost point, if rotates by 90 degree, speed becomes under root 4gl. See what has become inside the square root, number has got less by 2. Here 6 was there, here 4 is there. Now again by rotating from 90 degree, again number got less by 2. See, answer of the previous question at the top was root 2gl, na? Okay, so at the top I am copying the answer. What was the answer? Under root 2gl. So remember like that. Now on every rotation of 90 degree, number inside the square root continuously decrease by 2 while going up, and while going down it increases by 2. So see, from C to D if will come, again it is rotating by 90 degree. So again answer will now increase by 2 inside square root. So here it is 2, so it is 4. Or you can say at same level it is same. So like that you can remember the answer. Now next time if they give you, if I give you here 8gl, you will say here 6, here 4. If I give you here 7, here 5, here 3. And if the most important data of this chapter I give you, I think you have you are comfortable with this interpretation. Now tell me if you are comfortable with the interpretation or not. Tell me loud. Tell me loud. Then I will switch to the more important ones. Tell me loud if you are comfortable with the interpretation. Come on. I'm trying to look at your responses. Come on, everyone. Oh, very good. All thanks to you for being so much responsive. Your energy is my energy. So continuously increase your energy. I derive energy from yours. Okay. So see, If I give you here speed is root 5gl, here speed is root 5gl. Tell me in one go, what is speed at B, C and D? Type your answers, Very good. At B, answer is root 3gl. At C, answer is root gl. At D, answer is root 3gl. These four are special points. Here we do not need any calculation for speeds. Okay. Now it is a common sense for us. Okay. So copy this. Now we will do tension calculations at all these points. So vertical circular motion is in full flow, and actually vertical circular motion is not in full flow. You are in full flow because you are understanding. Come on, everyone. Get ready to take tension now. See now. This same problem, now I will tell you, they will ask in a second way. Right now what I told you, a string is there and I was revolving the mass connected to the string. Now they will tell you that I am having a large cylinder or a large sphere, and again I have purchased some goli. Kancha, whatever you tell, that wala kancha, okay. And that kancha is rotating on the inner surface of the cylinder. Is the problems exactly same or not? Tell me. Important thing is not goli, not kancha, not this string. Important thing is someone is in vertical circular motion or not. Definitely. Here, who is responsible for vertical circular motion? Tension. Tension is providing some force towards center. I told you for circular motion, force towards center is a must. If force is not towards center, circular motion is not going to happen. So here, who is responsible at any point? Tension. And in this case, I have already told you who is responsible. Tell me. Who is responsible? Tell me. Type your response. Who is responsible in this case? If I have taken a cylinder and on its inner surface, a goli is doing the motion like this. Tell me. Repeat, everyone. Response. Give response, everyone. Write, everyone. Type, everyone. Come on. Tell me who is responsible. Normal reaction. Very nice. So every answer will be same. So they will give you here speed is root 5gl. So what is here? Again you will tell root 3gl. Very good. I will come back to it in this slide now. So now, what is the point of interest is, this is a circle. Now they will ask you calculate tension at these points. So first I am calculating tension here. In a single diagram, it is not good to calculate. First, I will tackle these two problems. I already told you, question of string and question of this are identical. If they give you this situation, they will ask you tension. If they ask you this situation, they will ask you normal. But don't get scared, answers will remain same. So see, I am giving you that speed at the bottommost point is root 5gl. Calculate tension at the bottommost point. Find tension at bottommost point and topmost point of vertical circle. See, now tension has been asked, so force has been asked. So open invitation, I have to draw FBD. This is the question. In one case, this is at the bottommost point. These are rotated to the topmost point, and what is the tension there? This is a problem statement. Copy this and I will tell you how to do calculations. Give it your try for half a minute. Try to draw a BD in the first case. You try till then I am drawing circle again. Come on. Oh, 5 mg you have told. Okay, now see. By default force is T upward, mg downward. I always see, this is the ABD in ground frame, okay? And in rotating frame, what is the difference? Just for your query, I am drawing tension upward, downward mg, and downward centrifugal. See, away from center is centrifugal, and that is mv square by r. In ground frame, only these two forces are there. In rotating frame, three forces are there. And difference I have already told you. In ground frame, equilibrium is not observed. Centripetal acceleration v square by r is observed. And here there is no centripetal acceleration is observed. In rotating frame, what I told you, there is always equilibrium along radial line. So the moment you draw centrifugal force, there is equilibrium along radial line. So I always choose this method because acceleration has not to be tackled about. But see, equation from both the case will be same. Here also, if I write, since acceleration is in towards the net acceleration is toward the center. So what I will write, T must be greater. So net force equal to mass into acceleration. Mass is m. Net force is what? T minus mg equal to mv square by L. So see, T equal to what? Mg plus mv square by L. This equation I got no theoretically. Here also see, here directly you can tell me the answer. Acceleration is 0, so directly tell na, upward force equal to downward force. So T equal to mg plus mv square by L. That's why I always prefer this method, rotating frame one. So now put the data. So T equals mg is mg plus m by L. At bottommost point V was root 5 GL, na? So V square is 5 GL. So LL cancels and answer becomes 6 mg. 6 times the weight is the tension at the bottommost point. Not just 5 mg, it's 6 mg. Mg is also there, na? Mg plus mv square L. In exam they can ask symbolically also. Symbolically they can give you V and ask tension. So then answer will be mg plus mv square by L. Think like that. Oh, you have told answer. 2 mg, I think. 2 mg, I think is wrong. Let me reach there. All of you have copied, I think. 0 should be there at the topmost point. Very nicely answered. At the topmost point, answer should be 0. Now see. See the case. If here I give you root 5 GL. Here what is there? Root 3 GL. And what I remembered for this point? Root GL. I told you na? 2 subtraction at each point. Okay. If you do not remember, then first of all you have to calculate by using work energy theorem from these 2 points. Speed calculation by using this point and get speed at this point. Okay, I have already told you in the 2 slides ago, but I told you to remember. So here draw the FBD now. Mass is here, tied to a string like this. So string tension will be pulling it like this. Mg is also down, so T plus Mg is downward. Okay. Rotating frame gives me a better feeling, so I will draw a, see, center is here. So centrifugal force is away from center means top. So when mass was here, away from center was down. But when mass is here, away from center means up. So do not remember that centrifugal force is down or up. Remember like away from center. See the center and draw an arrow away from it. That is centrifugal force. Okay. So mv square by L, and you know V here is root GL. Put the value na here only. So m by L into V square is GL. See, LL cancels and it is mg only. Now write the equation along the radial line. What I have told you, equilibrium is there. So what I can tell, upward force is mg. Equilibrium equation equal to T plus mg. Mg cancels, T equal to 0. Okay. This is theoretically the minimum speed possible at the bottom for the mass to completely perform a vertical circular motion, because if you further reduce the speed, tension is already 0 at this point. Okay, if you further reduce speed here, speed at the top is also reduced and tension will become negative actually. Okay, the negative tension is not possible. Okay, so a famous theoretical, see, first question I told you na. Repeat one more question. Confusion will become clear. First question, here root 6 GL was there. If I tell you that bottommost point speed root 6 GL, find tension at the topmost point. Same method na. Okay, just for practice, do with a speed. If at bottommost point I give it speed root 6 GL, what is tension at the topmost point? So same FBD you will draw. Downward tension, downward mg, and upward mv square by L. Here everything in terms of V, so I am using mv square by L format. So if here root 6 GL, here root 4 GL, and here speed will be root 2 GL. So what I use here, m by L into V square means 2 GL, CLL cancels. What I get my answer? Upward is C 2 mg and downward is T plus mg. T becomes 2 mg. T becomes mg, sorry. Questions like this, if asked, they will be of good category. But thankfully, you can solve it because you have been so much responsive and active while understanding this. Okay, so see, root 6 GL was the speed at the bottommost point, tension was greater than 0. Tension in a string is a desirable quantity because what I told you, tension is the thing who is pulling it towards center, who is providing necessary force towards center. Okay, so for circular motion, force towards center is a must. Okay, string must remain taut, tension should never be 0 even. Okay, so if root 6 GL was at the bottommost point, it was okay because from doing all these questions, we have guessed that tension at the bottommost point is highest and at the topmost point is lowest. Lowest tension was mg with root 6 GL. Lowest tension was 0 with root 5 GL. Okay, so if I further reduce speed from root 5 GL, tension is already 0. Now it will become negative, so string will become slack. So if string will become slack, means string will become wrinkled like this. Can this mass be on the circle? Tell me. If the string is not tight, can the mass be on the circle or not? Tell me yes or no. Yes or no? Tell me. If the string is not taut, means slack, means wrinkled, can it continue to be moving on circle or it will leave circle and fall back? Tell me, come on, come on, come on. Fall back, very nice. So this is a theoretical and most frequently asked question. Minimum speed at the bottom to complete vertical circular motion. What will be the answer? Root 5 GL, root 5 GL. So now the remembering part. REMEMBERING, remembering part. I will remember, you will remember, time will remember this question. If this is a string, string always has a chance to get slack. Okay, so they will ask you minimum speed at A, B, C and D. Minimum speed, minimum VA, minimum VB, minimum VC for a vertical circular motion to happen. You must have understood whenever speed at A is minimum, speed at B will also be minimum, speed at C will also be minimum. We have established all three are related. So minimum speed A at A is root 5 GL, we have remembered. So if minimum speed at A is root 5 GL, many times in exam what they will tell you na, that they will tell you that your friend is throwing a ball from here. He must throw with what speed at B so that it can move a complete vertical circular motion. So throwing at point B, what should I speed? What minimum I should provide? Root 3 GL. Because if minimum at bottom is root 5 GL, minimum at B is root 3 GL. And what is the minimum at C? Root GL. Questions like this will be asked. Questions like this will be asked. Very good. At D also, root 3 GL. So get ready to tackle these types of questions. Here I have written string, word string I have written. Okay. Sometimes there is not string connected, there are rods connected. Thin rod you have taken. Rod by its name itself, na, rod is a rod. Rod never gets slack. Okay, so rod never gets any tendency to get slack. So slacking, condition of slacking is not here. Okay, so answer of string is not followed here. Okay, so rod can tolerate zero tension. Rod can tolerate any tension. Okay, at any tension, rod they never get slack. So for if they connected rod, now they will ask you what is the minimum speed here so that it can complete vertical circular motion. Okay, since now there is not any string, so no thought of slack should happen in our mind. Now we should think like, now here listen carefully. Now what should we be thinking? No tendency to get slack here now. Okay, so what should be our thought? Our thought should be that to get completely vertical circular motion, at least I should ensure that this must reach a stop. If reach a stop means what? It does not stop before reaching point C. Does not stop before reaching point C. If it stops before reaching, suppose it stops here, will it complete circular motion? No, it will fall back. It should never stop before point C. Then it can complete vertical circular motion. Okay. So now you can tell me orally. That for that I have to take speed here at root 4 GL, so that here it is root 2 GL and here it is root further 0. So root 0 GL means 0. Root 0 GL means 0. So minimum speed with the rod should be slightly greater than this root 4 GL. Slightly greater, what I am telling you, because if you take this slightly greater than root 4 GL, here it is slightly greater than 0. Slightly greater than 0 means it will cross point C and again fall back, rise, back, rise and fall back, rise and fall back like this. If you give exactly root 4 GL, what will happen? Now concentrate, what will happen? If you give exactly root 4 GL, this is rod, this black marker is rod. It will go up exactly root 4 GL. You go up, go up, go up, go up, go up. Here speed becomes 0. It will stop. It covers completely half a circle and stops. It will not cross point C because it is perfectly at rest here. Here what was happening in this case? At topmost point was speed 0 or greater than 0. It was root GL greater than 0. That's why it was crossing point C and falling back to complete a circle. That is the difference. So here at root 4 GL, it is not crossing this, but minimum's answer is like that only. But if they specifically write that if at the bottom root 4 GL speed is given and one option is having that it covers only half circle, then you will have to tick that option. Okay, this will be a highly conceptual question if asked. Okay, so minimum speed for VCM at A, B, C. At A it is root 4 GL, B root 2 GL, 0. Slightly, actual answer is slightly greater. I think you all are feeling good. Yes, Vaishnavi, very nicely answered. See, suppose my hand is a rod, na? It starts from this position. This is center, okay? So it goes and hangs like that. Because speed is perfectly 0 means it cannot cross this point. Goes and stops. This is the meaning of 0. Arivata told us, na? 0 is very important number. So enough for the day. Are you feeling well? Are you feeling good? Have you felt circular motion? Have you felt circular motion, or your head is doing this motion like that? Tell me, have you felt circular motion? Tell me. Come on everyone. I am dying to hear you. Come on. It's all your responses that will encourage. Oh, very nice. I am deeply heartened to hear your voices. Tell me fast. In exam also, many questions were, many people among you were asking questions. I was very happy with that you are studying in the exams. Some people were definitely thinking that, oh, I should not ask questions. Sir's vacation will become disturbed. I appreciate your thought, but you should have asked. Okay, some people I observed that they were asking, but in exam they were I think they were thinking about me, that sir will not answer my questions. Sir, can you please inform them to on comment box on YouTube? Yes, on YouTube I am not able to see comment. Okay, I will tell. Okay, so everyone, never get shy to ask me. I'm approachable. I'm always there for you. Okay, I will tell you too. Comment on. Acha, comment on YouTube is not enabled. You can solve complete circular motion now. Very few questions will be there that you are not able to solve. Actually, you will not be able to solve. But now you can solve entire module of circular motion. Go search each nook and corner of the module and solve. Like Maxo search for mosquito, become a Maxo and search for questions. Okay, so enough for the day. The schedule will come soon. Okay, so wait for that. Till now no information is there. So here is a QR. It's time to say bye, all of you. Bye everyone. YouTube notification not open. YouTube notification not open. YouTube the comments, students comments.
Live chat no.
Here no. Oh, they were telling.